and welcome to today's problem 125 valid palindrome. So, a phrase is a palindrome if, after converting all uppercase letters into lowercase ones and removing anything non-alphanumeric, it's the same forward and backward. So, alphanumeric characters also include letters and numbers. Given a string S, we want to return true if it is a palindrome or false otherwise. For this first example here, you want to return true because it is a palindrome. Reads the same forwards and backwards once all the commas and spaces are removed. And then for example 2, you want to return false because it's not a palindrome. If you read it forward and backward, the E and A is what conflicts. For the final example, we have just an empty string and you want to return true because regardless of how it's read, forward and backward, an empty string is still read the same way. So I'm going to keep that in mind. One way of doing this is by using a two-pointer method. So basically with the two-pointer method, I'll do with an example here. What we can do is we can basically have 2 pointers at the start, one at the start, left one, and the right one at the very end. From here, what we can do is slowly decrement, compare to see whether or not the characters are the same. So like R and R, check to see whether or not it's the same. And then we go ahead and move that forward, move this backward to see whether or not it's the same. A and A, we go ahead, move this forward, move this backward, check if it's the same. And then for situations where there's like an empty space here, right? So you have like this. We want to keep moving forward until we encounter an area where it's until we encounter a character that is like not a space instead before comparing it again. And at the very end, what we could do is compare and see what the if it reaches the very end, if the left pointer eventually equals the right pointer, then we'll know that it's true because it is a palindrome, and we can return that as the final answer. And if not, then we'll know that it's not, so then we'll return false. So yeah, if that makes sense, I'll go ahead and begin coding it up now. So we can start off first by initializing the left and the right pointer here. Left and equals 0, R equals 0. Oh, something I also need to mention is that we need to figure out a way to make sure that we're looking at the lowercase equivalents of them. So yeah, we'll go ahead and keep that in mind as we're going through this. So we want to check to see whether or not while the left is less than or equal to the right, at the very end we want to return true. If it does end up equaling each other, we'll know that we've reached our valid palindrome. And the next thing we want to do is, like we said, we want to check for any non-alphanumerics. So we're going to want to do while left is less than the right and not right and not the string at the left one is alnum. So if it's not non-alphanumeric, what we want to do is we want to increment that left pointer until it is. Same thing with the right one. While R, R is greater than 0, right? And not SR dot string at the right pointer is alnum. What we want to do is we want to decrement the right pointer by 1. Once we run through these two while loops here, we'll know for sure that the comparison between those two is between two actual alphanumeric characters. From there, what we can do is check to see if the string at the left pointer's lowercase equivalent is equal to the string at the right pointer's uppercase equivalent. So, lowercase equivalent for the right pointer. Basically, if these two do equal each other, then we want to keep going, right? Otherwise, we're going to want to return false. So maybe we'll do, if this isn't equal to each other, then we return false over here. So, and then at the very end, what we can do is decrement the left pointer, or increment the left pointer by 1. And then for the right pointer, we decrement it. So we do L plus 1, R minus 1 over here. And then we can keep going on. So yeah, if we can run this through again, full example over here, what's going to happen is we're going to have the 2 pointers at the start over here. We go ahead and check to see whether or not it's alphanumeric. Both are, so then we both check to see whether or not the same. They are, we move it forward. And then same thing again, both the same. We move it forward again, we hit C, we go ahead and check this again, and this time we encounter a space. So what will actually end up happening is this loop will trigger, right? Is greater than 0 and it's not alphanumeric. So we'll go ahead and move this pointer up until it is an alphanumeric, right? So while this loop occurs, before moving on to this one, right? And then we go ahead and compare whether or not these are equal. Well, they're not equal, so then I'm going to have to go ahead and return a false, which is the final answer over here. So the time complexity of the solution is O of n, because you're pretty much just iterating through every single element in the array until you hit basically until like the 2 pointers hit each other. And these 2 while loops, this actually just moves the pointer forward up until like you see like a scenario where it's until like it's a character again, so like it won't have anything to do, it won't have any effect on the time complexity as well. So yeah, and the space complexity of this is O of 1, because you're only just keeping 2 variables here. You're not storing any sort of values in the any sort of values that are dependent on the length of the string in the in an array or anything over here. So if we go ahead and run this now, right? Oh, right. So we actually need to initialize that right pointer onto the length of the string, subtracted by 1. Forgot about that. We need to have it start at the very ends before doing so. We also need to check and make sure that it's not the right being greater than 0. It only runs up until this case. So we have to check while the right is greater than left, right? So, well, I guess like while the left is greater than the right also. Yeah. Okay, one thing we could also do, instead of relying on the default is alnum implementation used in Python, we could have our own method called, maybe we'll call it like def is alnum over here, where we take in a certain character, and then we can check to see basically whether or not this character is alphanumeric by returning either checking to see whether or not the ASCII equivalence is between A, right? Basically between A and order of the character. Check to see within it's the same as Z, or we do the same thing with this one over here, or this one, A to Z, or from 0 to 9. So if we do that, if we go ahead and do that, then we can actually replace this, so we don't have to rely on a Python inbuilt function. So we can do is alnum, right? String left is alnum string right, and then yeah, we can do that instead. So go ahead and run this now. It'll still perform the same thing. Oh, sorry, unmatched parentheses. I see. Okay, fully accepted.